Solving recurrence relation through substitution method. Suppose we have this recurrence relation. So how we are going to solve it? First we write Tn is equals to 2t n by 2 plus n log n. Then we are going to write 2, then 2t n by 2 square plus n by 2 log n by 2 plus n log n. Then further we are going to solve it. So what we will get, 2 square t and that and 2 square t n upon 2 square plus and this 2 will be this 2 will cancel this 2, so n will remain n log n upon 2 to the power 1 we can write for 2, and this n upon log n upon 2 to the power 0 we can write because 2 to the power 0 is 1. So further we are substituting this 2 square 2t n upon 2 cube plus n upon 2 to the power 2 log n upon 2 to the power 2 plus n log n upon 2 to the power 1 plus n log n upon 2 to the power 0. Again we are going to solve it. So what we will get, 2 cube t n upon 2 cube plus this 2 square cancel this 2 square, so only n will left, n log n upon 2 square plus n log n upon 2 to the power 1 plus n log n upon 2 to the power 0. So if we do this up to k time, then what we will get, 2 to the power k 2 to the power k t n upon 2 to the power k plus n log n upon 2 to the power k minus 1, because here 3 and here 2, that's why if we write it k, so it will be k minus 1, this will be k minus 1. So like that we will get n log n upon 2 to the power 0. So further we are going to solve it, 2 to the power k t n upon 2 to the power k plus, now n is common in all, so we will take n common, and log, and we write from this side to this side, so log n upon 2 to the power 0 plus log n upon 2 to the power 1, like that we will write. So at the end we will get log n upon 2 to the power k minus 1. So k t n upon 2 power k plus n, this we can write like this. We have formula log a upon b is equals to log a minus log b. So by this formula we can write like this, log n upon log n minus 0, because 2 to the power 0, because we can say log 2 to the power 0 base 2, it means log 1, that is equals to 0 approximately, so we will write 0 here, plus log n minus 2 to the power 1, that is 2, then log 2 base 2, that will be 1. Log 2 base 2 will be 1. So that is 1. Like that we will do. So what we will get at the end, log n minus, this is 2 to the power k, this is 2 to the power k. So if we suppose n upon 2 to the power k is equals to 1, it implies n is equals to 2 to the power k. So if we take log, so what we will get, log n base 2 is equals to k. So from here, instead of 2 to the power k, what we can write? We can write log n. We can write log n. 2 to the power k, instead of 2 to the power k, we can write log n. So this will be log n minus 1. Log n minus 1. So again we are further solving it. 2 to the power k t n upon 2 to the power k plus n. This log n will be cancelled, so what is left? 1. So we are writing from this side. Like that we will get 2, 3, 4. 2, 3, like that we will get at the end log n. Log n. So this 2k cancel, this 2k, only n will left. So n plus n. 1 plus 2 plus 3 plus log n. So what it will be? It will be log, it will be n plus n log n plus 1 by 2. So what it will be? It will be n log n whole square. So this will be order of n log n whole square. So this is the solution of this substitution method.